Now let's see the addition and subtraction formulas of the inverse trigonometric functions. So let's look at this one here and let's prove it, and the others will become very easy to understand once you understand this one. So it said that sine inverse of A plus sine inverse of B is equal to sine inverse of A into under root of 1 minus B square plus B into under root of 1 minus A square. So how did we get here? Well, see this. Basically, if you say that x, let me not write it here, let me just write it here. Let's say that x is equal to sine inverse of A, right? So this is x. Let's say sine inverse of B is y, right? So y is equal to sine inverse of B. So clearly, if you take the sine inverse to the left-hand side of the equations, it becomes A is equal to sine of x and B is equal to sine of y. So A is equal to sine of x, B is equal to sine of y. Now, let's see what we can get for the cosine. We already know the trigonometric identity that sine square of g plus cosine square of g is equal to 1, right? So if you apply the same trigonometric formula and convert it for the cosine, it becomes cosine of g. Let me just rub this off. Just a second. Yeah. So cosine of g from this becomes equal to under root of 1 minus sine square of g. Now apply this one to both of these equations. So that means that cosine of x, wait a second, so cosine of x is equal to under root of 1 minus sine square of x, and similarly cosine of y is equal to under root of 1 minus sine square of y. Right? Now let's look at another trigonometric identity, which says that sine of x plus y is equal to sine x cos y plus let me just sine y cosine of x, right? Now apply that. We already have the values of sine x, sine y, cosine x, and cosine y, right? So apply those over here. So sine of x plus y is equal to all of these, and yeah, sine of x plus y is equal to sine of x, which is a, into cosine of y, which is basically 1 minus sine square of y, and basically that becomes equal to, let me just write that down, sine of x cosine of y under root 1 minus sine square of y. Now what was sine y? Sine y was equal to b. So what is sine of sine square y? It is b square, right? So b square plus sine y cosine x. Sine y was equal to b, right? Into under root of whatever cosine of x is what cosine of x. Cosine of x was equal to 1 into under root. So it was equal to under root of 1 minus sine square x, and sine square x is a. So under root 1 minus a square. Under root 1 minus a square, right? So x plus y would become equal to take the sine inverse function to the right hand side. Sine inverse of a into under root 1 minus b square plus b into under root of 1 minus a square. And so we already know that x was sine inverse of a, and y for sine inverse of b. So this is how you prove this first addition formula. And similarly, all of these that you see here can be proven by similar trigonometric identities, right? This one as well, using the tangent trigonometric identities, and this one as well. But yeah, all of them can be proven when you first equate these terms to arbitrary constants and then apply the trigonometric identities.